Welcome to video number 3, our third video of the night on surface area of prisms. And ladies and gentlemen, in this third and last video of the night, we are going to concentrate on triangular prisms. So if you take a look at a triangular prism, you took some notes on it from the book, it looks something like this. And you recognize that, hey, I've got this red shape at the top, it's a triangle, and we're calling that the base. And there's one down at the bottom. There's a triangle down there as well, and we're calling those the bases. So why is this a triangular prism? Well, that's right. Someone was paying attention in the previous video. That is because a prism gets its name by the shape of the bases. And in this particular case, that shape is a triangle. Now, if we want to find the surface area, I'm going to look at my trusty reference sheet here. And it says geometric solids, volumes, and surface area. And then I look over to right. Oh, I see rectangular prism. I see right cylinder. And I see right prism. Wait a minute, Mr. Ross. There's no triangular prism up there. No. How many of you were listening before? That's right, ladies and gentlemen. Every single prism is a right prism. So we're going to use the right prism formula to find the surface area of a triangular prism. It's a triangular prism because these bases are triangles, and we know they're bases because they are opposite, they are parallel, they are congruent. The three things we have to identify the bases. So surface area is 2 times the area of the base plus the perimeter height. That was not in your book, was it? There was a different one. We'll talk about that. So a triangular prism, right here, a triangular prism. It has 2 bases. They are the triangles, okay? They're the triangles right there. And those are the bases. And then, since it's a triangular prism, it has 3 side lengths to the base. That means there are 3 lateral faces. You can't see the third one. It's in the back, but it's there. It's purple. So if we flatten this out, open it up, flatten it out, and make it into a net so we can see every single surface. We've got the 2 bases. They are red. The 2 bases are red. Nice. And then we have the 3 lateral faces. And what is the shape of every one of those lateral faces? Oh, that's right. They're all rectangles. And when we put them all together, they form one gigantor rectangle. That might come in handy in a few moments. So, ladies and gentlemen, the formula that you probably took down from the book. Don't you just love these books? Again, math is not about everything that comes out of a book. There's better ways sometimes to do things than the way some of these people write these books. I'm not knocking the book that much, but I am saying, hey, let's take a look at some other things. But let's show that this does work. So from the book it said, hey, the surface area of this triangular prism is found by taking the area of the bases and adding that to the area of the lateral faces. Okay, we understand what the bases are. They are the shapes that are parallel, opposite, and congruent, and those are triangles. So let's do that right now. Let's find out the area of these triangles. How do we find the area of a triangle? That's right, base times height divided by 2. So we're gonna work this. I hope you're copying this down. We're working this. And we look at this triangle here, we see that we have a base and a height right here. How do I know one's the base and one's the height? Because they are perpendicular with that right angle corner in there. So I've got 3 times 4 divided by 2, which is 12, divided by 2, which is 6. So the area of this base is 6. Well, I know that if bases are opposite, parallel, and congruent, that the opposite base also has an area of 6. All right, so we have that. The area of the bases we know is now 12 because we add the 2 together to get 12. All right, now let's get the area of the lateral faces. So we have 3 of them. We're going to start with the blue one. And we get this by going base times height. And that is 4 times 6. And we get 24. All right. So we have a 24 plus. And let's go to the purple one. Once again, we have another rectangle. Base times height. And that's going to be 5 times 6. Here's the 5 times the 6, the height. And that's going to be 30. So I come over here and add my 30. And then I go to the green, 3 times 6, because it's another base times height. So 3 times 6, that's 18, plus 18. I add them all together, and I get 84. And that, of course, is going to be meters squared. Well, that's all fine and dandy, but once again, that's a lot of work. That's a lot of work. Ladies and gentlemen, let's do our formula. 2 times the area of the base plus perimeter times the height. I'm going to clear all this out. All right? And we're going to do it. 2 times the area of the base. Well, we've already done the area of base. We're not going to repeat it. We've already done it. We did the base times the height. We divided it by 2. But I do want to show you something. Since we have 2 of them, and I'm doing the area of the base times the height divided by 2, please recognize every time you have triangular bases, well, this 2 is going to simplify out with that 2, and you end up, when you put 2 triangles together, you get a rectangle. So you end up with base times height. So 3 times 4 is 12, so that's why this is a 12. All right? Because we had a 3 and a 4 there. All right, now let's do the perimeter. Remember, perimeter is the distance around the base. Okay, well, here's a triangular base right here. Okay? And that length right there around that triangle is also equivalent to this length right here. I'm going to get yellow and highlight it with yellow. It's this length right here. Okay, so we have 3 plus 4 plus 5. What is that? That's right, that's 12. 3 plus 4 is 7 plus 5 is 12. So, can't do it with that. Let's go blue. Plus 12. And, of course, the height, the distance between the 2 red spots, that's going to be equal to 6. So 12 times 6. Well, what is 12 times 6, ladies and gentlemen? That's right. 12 times 6 is 72. And what is 12 plus 72? 84. A lot less work. Meters squared, of course. Let's do a couple more examples. Here we go. I always love to highlight the base. So here I have the base right here. It's a triangle. I recognize it. And the other triangle is back there. So I'm going to go with 2 times area of the base plus the perimeter times the height. And I'm going to say, hey, the base, it's a triangle. I got 16 for the base and 6 for the height. So this is going to be 2 times 16 times 6 divided by 2. And then I've got the perimeter. The perimeter of that base right here, the distance around that. And that's going to be 16 plus 10 plus 10. That's 36. Times the height, the distance between the 2 bases, that's going to be 8. So let's do our math. Once I fill in the stuff, we can do our math. So we recall that these 2 simplify out. 16 times 6, that's 96. And 36 times 8, that's 288. And when I add these 2 together, I get 384. That's right, 384. That's inches, and that's squared. Voila, presto, bango. Pretty straightforward. Again, this math is nothing more than recognizing stuff using vocabulary, substituting in the values into the literal equation, the formula, and then solving the equation using order of operations. So once again, one more example. Here we have, again, the triangular bases, because we're going to do 2 times area of the base plus the perimeter times the height. Always write that down. Always highlight your bases. Start filling in your numbers. So 2 times, and we have a triangle. Where is the base and the height? That's right, they've got to be perpendicular. So I've got this side here of 12, and I have this side here of 16. So it's 12 times 16, and that's divided by 2, plus the perimeter of that, 20. 20 plus 16 plus 12. 20 plus 16 plus 12 is going to give us 48. And then we're going to have the height. The distance between, that's only 4. Doing our math using our calculator makes it easy right there when the 2 simplify out. 12 times 16 is 192. 48 times 4, guess what? 192. Add those 2 together. I didn't do this on purpose. 384, the exact same surface area as our previous example, even though they're different triangular prisms. Didn't do that on purpose. All right, the last thing we're going to do tonight is we're going to do a real-life application of surface area, and we're going to use this little carol. You may have seen these in the, they used to be real popular a long time ago, but now we have so many cell phones you don't see them as much. But these little carols that are designed for public telephones. And it says that the airport designed this carol for the public telephone usage. How much aluminum is needed to make the carol? So we can recognize that this is part of a rectangular prism. It's part of. It's not the whole thing. So you're probably not going to use the straightforward formula. you're probably just going to say, hey, I've got some sides that I got to just find them. So I have this bottom side right here. I'm going to call that number 1. And then I know that this side over here, it's parallel, opposite, and congruent to this side over there. So I just need 2 of those. And then I have the last shape back here in the back. So let's do all 3 of those. And every single one of them is what shape? That's right, a rectangle. So for number 1, what are my units? I got 26 here and 13 there. 26 times 13. Okay, 26 times 13, that's 338. And then I'm going to go to shape number 2. So I have this rectangle here. That's 45 and 13. So number 2, I have 2 of them. And I've got 45 times 13. So 45 times 13 times 2 is 1,170. Wow. And then I come over here to shape number 3. And that's this one in the back. So it goes kind of like this, and it would go like there. So there would be the one in the back. You can't see part of it, but it's there. And the units for that base times height is 45 times 26. Well, guess what? 2 times 13 is 26, so 45 times 26 is 1,170. So now all I have to do is add these 3 up, and I get a grand total of 2,678 inches squared of aluminum. Voila. All right, ladies and gentlemen, I know it's taking a little while. It's a long night of notes, but it's really important. And you need to do one more quick write before your night is done with this surface area of this prism. So please give it a quick draw. Again, you can take and draw a triangle, and then you can take and draw another triangle. It's kind of similar. Connect the vertices, and you have your triangular prism. Label it 5, 12, 2, 13, and from that, you need to find the surface area of this triangular prism. And you can come to class with questions, surface area of prisms, whether it be rectangular or triangular, and then begin working on your assignment. Probably not a ton of time left, but I'm hoping that you have a few minutes to get started out of your 45. Thank you so very much for your cooperation, participation. You guys are amazing. I will see you in class tomorrow. Let's get ready to rock and roll.